Hey Mr. Marty, this video is made by Andrew Bramlett, McKenna Bradley, Garrett Finn, and Geneva Werner, and it is about how to do even-odd functions graphically and algebraically, and how to do fractions as well, and then we'll also learn about the shortcuts. So if you can get out your homework number 11, which is this sheet, then we'll try to revindicate our terrible grades so we can get in. Okay, so I'm going to teach how to do it graphically. So first we have this partial graph given in black, and we're going to try to make it even. So we have to sketch the rest of the graph to make it even. To make it even, it's going to be reflected over the y-axis. So you take this piece right here and flip it there, so it's going to keep going, and you see the point at -1, just like -1 reflected. And then you see the asymptotes, which are both at both 2's, because that also reflected, and then the piece, that third piece, is flipped too. Second one is not drawn in yet, so we're going to flip this one. That point at 0, 1 is going to go to 0, -1, and 0, 3 is going to go to 0, -3, because all you're going to do is flip it over that axis. Then the third one is we are trying to make these odd. If it's odd, it's going to be rotated from the origin. So this is going to end up turning into a point like this, where it looks like the parent graph of x cubed, and it's going to have that point at 0, 0. And then the point with the asymptote at 2 and then the point at 0, 3 is going to be reflected, or rotated rather, over, so that the asymptote will still be at 2 and that point will be at 0, -3. And it'll be like a different, the curve will be negative rather than positive, how it is. And then the last one, since you're going to be rotating at 180 degrees, that it's going to be, instead of pointing downwards, it's going to be pointing upwards, and it's going to be in that quadrant, so which is quadrant 2. So that point at 2, -1.5 is going to go to -2, 1.5, and the point at 1, 1 is going to go, or 0, 1 rather, is going to go to -1, 0. I said that wrong. The point at 1, 0 is going to go to -1, 0, and the point at 3, 0 is going to go to -3, 0.
My name is Garrett. I'm going to be explaining how to determine whether an equation is even or odd algebraically. The first equation we have up here is f of x equals 4x cubed. Now, first thing you want to do is change all the x's to negatives, so we have f of -x equals 4 -x cubed. And we have the same thing, f of -x equals, and then you take this and you cube it, and -x cubed is still negative because it's odd, and so you put the negative out in front, -4x cubed, and this would be an odd function because it's the opposite of where it started. It's negative here, it's positive there, it makes it odd. The second one, we have f of x equals -3x squared minus 5. We're going to once again put the -x in front. F of -x equals -3. We're going to put -x instead of x. -3, -x squared minus 5. -x squared is negative. No, it's positive, so we're going to keep the negative out in front. So f of -x equals -3x squared minus 5. And you can see that these two are the same. F of x is the same thing as f of -x. I'm making this an even function. And the third one down here, we have y equals x squared plus 3x squared plus 2. Once again, we make all the x's negative. And then we have the first one, -x squared. -x squared is back to x squared, so it's still x squared because it's an even exponent. Move over to the 3 -x squared. Once again, 2 is the exponent, so it goes back to positive 3x squared, and then we keep the 2. And you can see these